Welcome to your second day of Moab.con, everyone. Thanks for coming again. My name is Josh Butikofer. I've been with the company for several years. I was one of the earlier employees. So I've worn a lot of different hats in the organization. I've been in development. I've dabbled a little bit in sales. I've been in professional services. I've also been involved in the architect role, which is where I'm at right now, helping to architect our products and solutions. My title is officially Chief Solutions Architect. But basically, try to help our engineers and our customers hook up together and figure out how to make our products better in the future. So, today I'm going to be talking about policies, tips, and tricks, is the title of the presentation at least. And we're going to be covering some seldom used policies, or at least policies that are as well known to some of our customers as to others, but are nonetheless gems in the rough, so diamonds in the rough. And also we're going to be talking about how to use these use these policies and understand that they're working correctly, and also understanding how you could turn these policies on without actually turning them on, so kind of simulating them in your environment. So this is sort of some of the things we'll be talking about. There's a lot of policies. So you heard earlier in some of the sessions that there's thousands of policies. That's a little bit of exaggeration. There's probably thousands of permutations of settings and policies that we may have. But there's so many of them, I'm going to have to put them all in bullets on PowerPoint, and I might have to go sub-levels. So if some of the text gets kind of small to read, that's okay. You're going to get the slides after the presentation, after the conference. So you can zoom in and stuff at that point. So just bear with me. So here's some of the fairness policies. So there's active and idle and system job limits. You can see that little tip there. It's important. We don't have time to go over it, so there's too many to cover, so we'll just go quick. So fair share. Everything that's underlined is really important, so you got to memorize it, okay? Let me just read this because it's so important. Fair share allows historical resource utilization information to be incorporated into job feasibility priority decisions. This feature allows site administrators to set system utilization targets for users, groups, accounts, classes, QoS, and loads. So, really important. And if you can read these small things down here, like there's one tip there about fair share targets, and another one says if you can read this, you haven't yet experienced death by PowerPoint. And then that smallest tip there is really important, but you're going to have to zoom in after you get the slide back. And if you enable policies, you will feel like this guy that just zoomed up on the screen right there. So if you use policies, your systems will look like this, very well organized. You will achieve this success. This is one of your customers after work running to a fill. This is how you will feel inside, and this is the magical power that you will have. So, obviously, I'm being a little tongue-in-cheek here. Policies are a great thing. We're going to talk about what exactly they are, and be a little pragmatic about them as well. So they're not going to solve all of our problems. They're going to help us, however, protect against these kinds of people, so disgruntled users. Or problems in our system, right? Not just users. There's all kinds of issues. There's politics, there's resource constraints, you've got failures, all kinds of things that Moab's policy engine is supposed to help us with. And hopefully after this presentation, you'll get a little better feel for that. We're only going to be able to scratch the surface, but I hope it's going to be a good introduction. And to help us along this journey through this presentation, we have Moab. So Moab knows that Moab is a policy engine, an intelligence engine, as the marketing team tells us. And it's true. I'm not trying to downplay that at all. But hopefully he can guide us through this process. So first of all, we need to understand what a policy is exactly. Because we use this term a lot, and it means a lot of different things to a lot of different people. So for at least this presentation, I'd like to come up with a few definitions we can use as a working set of nomenclature here. So you're not going to find this in the documentation, and you're probably not going to find this in any marketing materials yet. I hope someday we are going to be able to put this in there to kind of better define or lay out exactly the difference between a policy and configuration and so forth. But I actually am going to read this because it is important. It is an expression, a policy is an expression of a business requirement that can be applied to workload, resources, users, sites, and/or groups. It changes behavior or makes a decision that affects workload and the usage of resources. Okay, so I'll have some concrete examples a little bit later. So that's a policy, a high-level policy, I should say. Configuration is a little bit different, at least from my perspective. It is a setting that changes Moab's behavior, but does not make a decision or map completed business requirements. So an example of configuration is something like your log level in the Moab configuration file. That changes how verbose your logs are, right? How detailed they are going to be. Another example of a setting are all of the settings you attach to your SCED CFG setting. That's like your port, your hosting. RMCFGs, those are kind of settings too. You're setting up your resource manager, configuring it to communicate with Moab and vice versa. So that's configuration. But then we have something else. Building blocks of policies, okay? And I kind of group these different from our high-level policies and our low-level policies. In the past, sometimes we've talked about policies as reservations and triggers and event thresholds. And those can help you achieve some sort of level of business requirement implementation in your system. But oftentimes we're combining these together to actually create the things we want to achieve. And so in that sense, they are building blocks. And so I kind of differentiate them in that way. And here's some examples. On your right, you have policy building blocks, such as placement rules. This could be like your node allocation policies. Thresholds such as generic event thresholds that are also, these thresholds can also be attached to triggers. Events, node sets, affinities, and reservations. Okay, so on your left are your high-level policies that these right-side building blocks kind of create, or you combine them together to make these composite things. So things like preemption, fair share workload allocation, usage throttles, allocation building settings, via migration, server commit, and the others you see listed there. So now that we've kind of gotten our nomenclature down, let's talk about some secrets of policy management. So these really aren't that secret. A lot of you, as I've interacted with you during the conference and seen some of your presentations, already know about some of these. But some of you that don't, it's still useful for you to know. So I basically took about 100 configuration files that we gathered from our support system, and I ran them through little scripts I've written to do some data mining, to understand what configuration was the most used amongst our users, at least out of this random sample of 100. And I found that I have found some surprises. A lot of you do use the rack labels, which I didn't think was that popular nowadays. But I found that some of you were actually not using some of the policies that we, as Moab engineers, think are the most valuable. And so I'm going to cover just 3 or 4 of those briefly here. And there may be others, but because of the time restrictions and limits, we won't be able to cover all the things I discovered, but maybe we'll be able to publish this later, or you can contact support or me or others in the conference to maybe get some more secrets. Nonetheless, the first thing I want to talk about are the high performance settings in Moab. We've already seen some presentations on this. There's not going to be much overlap though, so don't worry, this is not going to all be a repeat of what we've already seen. But there was a high performance presentation earlier, and they talked briefly about high performance setting, specifically the enable high throughput parameter, which I'll show you an example of in the next slide. But I wanted to go into a little bit detail about what the high performance setting actually does. It obviously improves performance, right? At least hopefully, because that's what the label it says it would do. But what it actually does is short circuits a few things in Moab scheduling in order to achieve this higher performance. Normally, when you submit a job to Moab and use MSub to do so, it will immediately try to schedule that, or not schedule that job, immediately try to send that job down to an underlying resource manager, whether that be Torque or Slurm or something else you hook Moab up to. And it does that in order to return to the user that issued the MSub command the job ID, the Torque job ID of that actual job. It does a whole bunch of other checks and balances and things in there as well as part of the processing of that job before it sends it to the resource manager. Well, when you enable the setting, what Moab does is it does not do that. It short circuits that. It will receive the job, checkpoint it immediately. First of it receives the job and assigns a Moab ID to it. So your ID is going to be something like Moab.212 or something like that, depending on where your counter is. And then it's going to immediately checkpoint that job in the file. So if Moab crashes at that point, and you bring Moab back up, or something happens, Moab doesn't crash, right? So something happens with the machine rebooting, then you're going to be able to bring Moab up, and that ID is still valid. In other words, it's transactional, at least from that perspective. And that job ID, that Moab job ID, you can use to interact with that job at the Moab level throughout the life of the job. So it's just as good as the Torque job ID, except where you can't really use it in Torque. So if you're using QSET stuff, there's some problems there. But that's one of the, and also because it's not submitting the job immediately down to the resource manager, it can cut through a lot of the other things. So what does this mean to us? What does this mean? This means that instead of submitting maybe 1 or 2 jobs a second using MSUB, you can submit 10, 20, 30, 40, 50, maybe even 60. Sometimes, if you're lucky, maybe even up to 100 a second. And if you're using job arrays in this setting, I think you'll maybe learn about job arrays later in the conference, I think, or maybe you already have one of the sessions. You can submit even more, right? Lots. I mean, we touted 1 million jobs in Moab during our keynote. Using job arrays, you're going to be able to get to that scope and size. So, and with the set. Now, so one of the other things it does is it takes a little bit of quote-unquote shortcuts in scheduling. But we found that most of these shortcuts a lot of users don't really care about us taking, and that is no partial load reservations. So, as many of you know, a reservation is a way to cut off or slice off or cordon off some resources and assign it to certain users or reserve it for maintenance, whatever. But a partial load reservation is you're slicing off a part of a node, not an entire node. And that's a little bit more complicated from Moab scheduling. And if we just disable that, and user doesn't, and customers don't mind about disabling that functionality, we can be a lot faster. So turning this setting on, it's pretty easy. This is it. This is the configuration you do, and you simply set this, and then you need to restart Moab. And you also need to make sure that any client command mode configuration files, because sometimes you'll have an interactive node that has a different configuration file than your actual Moab daemon head node. He needs to have this in there as well. So both the client and the server need to know about this high performance setting in order for it to be in full effect. All right. Well, yeah, okay. The next thing I want to talk about are ACL modifiers. So first of all, what is ACL? Access control, and it is a way to restrict access or allow access to a reservation specifically. So an analogy that we often use in training is a reservation is a lot like going to a theater. So, or going to some sort of event where you can, and you imagine that each seat is actually a node or a server, okay? And we are the jobs going there to that particular theater or a particular event. And reservations are simply a way for the theater to guarantee that as you, as a job, as a user, as a customer, the theater gets a seat in a particular slot. So these ACL modifiers control how you get access to that theater. So, for example, most theaters have a policy that no shirt, no service. So they do not want bare-chested people walking into the theater and embarrassing themselves and others in the theater by not being fully clothed. So that's a way to prevent access to the theater, right? Another way is requiring access. You need a ticket to get into the theater. Okay, that's one way you can modify the reservation. A way that people don't need tickets is, it's more of a festival seating where they've got certain seats, certain amounts, and they just need to make sure they don't let any more than that in the door. Last but not least, one of the most useful ways to do something in the theaters have like VIP seating. So if you're a VIP, you have to sit in these certain nice seats. Or if you're a lowly undergrad student, you have to sit in the very front. Different things that they will do that way. And it's just the same way more with reservations, okay? You make a reservation over certain nodes, and using ACL modifiers, which I'll show you how they're exactly used in the configuration file, but you use these simple characters to denote prevention of access, requiring access, and force restricted. So if you want to say a certain credential does not have access to these resources, this reservation covers, you put the bang, the exclamation mark. If they must have this attribute, then you do the asterisk. And if you want all people that fall into a certain credential group to be forced into that reservation, to cred lock them, as we call it, then you use the ampersand. So this is how it will look in the log configuration file. We're defining here a standing reservation. You can read more about this in the documentation. You just search for SRCFG, so it stands for Standing Reservation Configuration. We're defining one called vault. Now this is not a complete definition. This is just only the relevant lines for access that you see here on the screen. There'll usually be more information about the actual resources, time frames, that sort of thing. But here we have an account list. Now I don't know why we're taking on the chemistry department today, but these particular reservations, they do not have access to these resources. Maybe they didn't pay enough in the funding committee, but they're not allowed to have access to this reservation. And then the next line, you see a QoS list. So a quality of service is a way it's still a credential, but it's kind of one of those weird credentials. It's not like a user account or group. It's kind of a special access one. It gives you special privileges. And if you've been granted access to this quality of service, you've been given superpowers, kind of like Moab. And in this particular instance, we require for someone to use the Vault reservation to have this quality of service assigned. And last but not least, John, every time he comes to the system and wants a node, he has to go to this reservation. He also has to have the quality of service high, by the way. These are all added together. If his resources are full, because other people are running in them, he's going to have to wait in line. He can't go someplace else. It locks him in his resources. This is very useful, as you can imagine. In your politics or business needs or organization, you can use this to make reservations in the system to guide the workload automatically. Have Moab intelligently, quote unquote, policies manage your resources without having to micromanage. So that's why these are very useful. Now, of course, these can apply to any credential. So I could have very well said account list equals geology and give it an ampersand, meaning all the geology department also has to run these resources. So these apply to any credentials, and you can learn more about them in the documentation. All right, one of the last ones I want to talk about are our secret policies that we think are pretty cool that not very many people are using it. And this one, probably because it's fairly new, it came out in the, I think, 6.0 or the 6.1 release, is generic resource throttle. So first of all, what's a generic resource? A generic resource is a consumable resource that is defined by you or by a resource manager. It's not memory, it's not CPU, it's not disk, it's something different. So what does it mean by a consumable resource? Well, it's a label, say for example, a license, MATLAB, and it has a quantity. Say for example, 10. I have 10 MATLAB licenses. It's consumable in the sense that when a job comes around, like Pac-Man, it eats one of those licenses. So now you only have 9 left, and Pac-Man has eaten one of them. Well, when Pac-Man dies, the job expires, he's going to relinquish that one license, and it goes back to the pool. So in other words, these things, once 10 have been eaten up, jobs have to wait in the queue till more become available. And as jobs relinquish their licenses, or their generic resources in this case, they're added back to the pool. So, generic resource throttling means that we now have a way in Moab to control on a per credential basis, that means per user, per account, per group, whatever, what kind of high limits that people can use for generic resources. And this is very useful, of course, for licenses, as we see here. That's the actually number one usage for generic resources. It's most of our customers. It's for licenses. Because as you know, software licenses are very expensive. And depending on what filter, they may be more expensive than even your hardware at the end of the day, over time. So let me show you an example of how this looks in the configuration. Here we have a user CFG, a user config. It's a way for us to restrict certain users. The second line, you have an account config. You can do this with groups and other things as well. You look in the documentation to get a little bit more information. The first line, we're specifying user Bob, and we use this max gres throttle here to restrict the maximum amount. And then we specify the generic resource name here. And then we say equals 2, 4. Now, this is a soft and hard limit for you, for those of you not familiar with that. Soft limit says if the resources are available and no one else is really using them, they're not in high contention, Moab can let you go over to your soft limit. So Bob, if he needs more than 2, that's okay. He can go over that if they're available. You know, if there's not a lot of contention for the resources. However, under no condition can Bob use more than 4. That's our hard limit here in this scenario. In this one down here, they have a hard limit specified of 4. For the account chemistry, they can only use 4 MATLAB licenses at a time. Now, how do you get generic resources into Moab? There's different ways you can do that. You can actually, you can actually configure them in the Moab configuration file using the gres parameter, and they can be either on a per node basis by actually attaching specific nodes to the node CFG, or you can attach them to something called a global node. That's global all uppercase, GLOBAL. And once you define them, attach them to that configuration file, they're available to any job. See, if they're attached to a specific node, only a job running on that node can consume that resource. But if they're attached to global, a job can run on any node and consume one of those resources. So it's flow. Another way you can get them into Moab is through a native resource manager. I won't explain that yet because we're going to talk about that in the presentation. Just remember. All right, so we have talked about some of the secrets for the policies. Now we're going to talk about some tricks. We often come to a scenario like Moab is saying here, where we have configured policies and settings in a Moab. We set things up just right, and it's been running for weeks or months. And then a user comes to us and says, my jobs just aren't running well. Something's wrong with Moab, or you're not doing your jobs as a sysadmin, I'm going to be fired. And so you need to be able to go back and trace what Moab has done so that you can find out exactly what's going on. You have to be able to follow an audit trail, so to speak. And the way that we can track policies, one of the ways I should say, is through these event files. Now, I know that some of you have not used event files before. Some of you have. So let me briefly explain what they are. They're different than the Moab.log file that you find usually in the Moab log record. That log file can be very verbose and it can be very detailed. It's very good information for some people who've been around Moab for a long time. That may be people in your organization, but it usually means adaptive computing support personnel or engineers in adaptive computing. If you have a particular squirrely or difficult problem, we may ask you for the Moab.log files to help understand your environment and see what's going on. But for those of you who may have tried to read those files yourselves, they may not be very easy for you to diagnose. So what I have found in my own experience and in helping other customers throughout the years is that the event files can be a much more valuable resource when the problems aren't that severe or tricky, or what you're trying to track down is not tricky. They're found in the Moab stats directory, by default at least, and they're unique because unlike the Moab.log file, which are bounded by size, they're bounded by day boundaries. So every day you have a new event file. And this is nice because when a user calls you with a particular concern or problem, or you have a question about something that happened in the past, you have an idea of maybe when that happened, and you can go back to that particular time and look to that particular file. Another nice thing about the event files is they provide just close to just right, the Goldilocks amount of detail. They talk about the high-level events in Moab that you might be most interested in, such as when a job starts, a job submitted, when there's a failure, when a node goes up or down, those sorts of things. And it's not going to tell you about specific minute details about the scheduling or the processing of job completion that the Moab.log file usually talks about. But by default, depending on how you configure Moab configuration file, I should say, Moab may not be writing out to these files. You might see them, but they might be completely empty, just 0 byte files. In order to control what Moab is actually logging into these event files, you need to use the record event list parameter. And you can look in the documentation for more of that, or we can talk about some of the sample events here as well. So the record event list parameter allows you to specify a list of event types you wish to have logged in these event files. You can also specify the all parameter, which is all caps, which says log everything you've got, Moab. But doing that, you might want to try that out. But doing that it may defeat the purpose of having the event logs because it's going to spit out a lot of data again. Not nearly as much as Moab.log, log level 7, but still a lot of information. Some of them might be redundant. But for those who want a safety net, that are not going to lose any information, that may be worthwhile. It should also be, hopefully, somewhat apparent that if we're logging less data than the Moab.log file, these things are not going to grow huge. Most of our customers, the largest they get in a day is 100 megabytes. Maybe that's large to some of you, but that's pretty small compared to the gigabyte files you can generate with Moab.log. So another thing I want to mention real quick, it's kind of out of order, but these event files can be very valuable. If you stop relying on them to be your audit trail for things, you need to archive and back them up. Moab's not doing that for you automatically. Again, someday it will. But once those event logs have been created, it's really up to you to decide how you want to back them up, compress them, archive them, and so forth. Okay, so back to the event types here. As you can see, they deal with certain objects in Moab, usually kind of object or subject point. You have ones related to jobs, those reservations, and I'll talk in more detail about the schedule and RM pool. First, I want to say one thing about the job submit event. This one can be a little tricky, a little confusing, because this event is fired inside of Moab and logged to those files every time you have a job that's submitted to MSub, through QSub, and Moab discovers it, and every time Moab is restarted. Every job in the queue, you're going to get a job submit event. So that's tricky, right? That's tricky. But luckily, there are some ways to tell if it's being loaded from the checkpoint file, which is what happens when you restart Moab, or if it's a fresh submission. And that's a little message attached to the event that says this job was loaded from the checkpoint file. Either that, or I can't remember if it says it's loaded from the checkpoint file, or when you submit it, it says it wasn't. In any case, it'll be clear to you where it came from, or it should be clear. And so if you're using event logs and you restart Moab, every once in a while, don't be alarmed when you see, oh my goodness, Moab is resubmitting all these jobs that we already had in the queue. No, it's just part of its loading process. So the others are pretty self-explanatory things. Job start, job end, cancel. The difference between end and cancel, of course, is one was a cancellation. Job was aborted basically as opposed to it ending gracefully and naturally to the job end. Job failure. Okay, so node down, node failure. Those are pretty self-explanatory too. Or node goes down. There's also a node up event. Usually the node up event's not that valuable. Maybe it is. Depends on your situation. But one thing to be aware of node up, every time you reboot Moab, Moab's going to see all those nodes come up the first iteration. So you're going to see a lot of events happen there. All right, reservation, pretty self-explanatory. Let's talk a little bit about scheduling. Now, what does this mean exactly? The sched start, sched stop, sched pause. Well, it sounds pretty simple at first. They just fire events every time Moab is started, or stopped, or paused, or shut down. But if you could imagine, that could be actually very valuable. Once I had a customer call me in the middle of the night. I was on the phone, and they valued their uptime a lot, so much that they didn't care about my sleep. So they called me and said, Moab is shut down, it's crashed. But, we need you to diagnose it, because they were afraid to turn it back on themselves. And so I got on the system, and I looked around, and after I kind of woke up a little bit, I realized, well, I need to look at the event logs. What happened? Maybe it was shut down. Sure enough, someone shut it down. And I could see the username, and I told them, and I was able to go back to bed, and that person got woken up and got shut down. So this is very useful. Yeah, this is me passing the buck, exactly. And it's you passing the buck, hopefully, right? Or helping to understand what happened, in the situation, right? Knowledge is power. So, sched pause, that's another valuable one too, because sometimes you may have experienced this, jobs aren't running in the queue, and people complain, and it's because someone paused the scheduler. Well, show queue will tell you at the very bottom, so-and-so paused the scheduler this long ago. But if you're not looking at that, and you can find out who paused it in the event logs in the past. Maybe someone keeps pausing it and restarting it, and so users are seeing these intermittent failures or problems with jobs being blocked. You can look in the event file and verify and find out who it is. Okay, so enough about the scheduler stuff. The other one that's important is RM poll, start and end. So there's a scheduling cycle, iteration inside of Moab, and Trev actually yesterday gave a great presentation on that. He went into great detail about that and explained all the different sections and parts of that scheduling iteration. And I won't be able to repeat that here. But the RM poll start and end mark the beginning and the end of that iteration. So in your event files, you can see what events happened right after the scheduling iteration began. So that's Moab doing all of its actions, and then when it ends. And then everything outside of those two fence posts are going to be things that happened because of user interactions with Moab, for the most part, or things that happened outside of the scheduling iteration. Another thing this is nice to do is, Trev, I think, also showed you the mdi-cap s command yesterday, which helped you get
real time or some aggregated statistics about where Moab is spending a lot of its time during the scheduling iteration. Well, if every time you restart Moab, those statistics are reset. And it may only keep up to a week. Well, the event logs, if you're keeping them for a long time, you can mine that data, and you can find the endpoint, and the beginning point, subtract the two, and find out your average scheduling iteration over a longer periods of time. You can see peaks and valleys, and understand what's happening inside those scheduling iterations, causing those slowdowns or speed-ups. So, very valuable, at least I think so. And if you are lucky enough to be running virtual machines with Moab, using some of our cloud features, you have virtual machine events as well. Okay. One thing about the event files in the past, and maybe some of you will experience this, is they're not very human readable. And they're, to some degree, not very machine readable either. What I mean by that is, because of the way they're formatted, it's even hard for even those Perl experts out there to write something to parse it. And I'll show you why in the next slide. But there's a new parameter as of Moab 6.0 called the Wiki Events, true. And setting that to true will give your events a makeover and make them appear much more human readable and machine readable. Now, what does Wiki mean? Maybe we've covered this before, but I just want to say real quick, Wiki is Hawaiian for quick, and back when Moab and Maui were developed, Wiki was the language that they would use to communicate with resource managers. So we're renaming it now the Moab RM language, and getting away from Wiki because, as you know, Wiki means something very different now to most people in the world. It means a wiki online. So unfortunate historical naming, but you can find more information about events in general in the section 14.2.7. So let me show you an example of a pre-Wiki event. Sorry for those in the room over here that will have trouble seeing this. But you will get these slides, and you will not have to zoom in on this particular one. So here you have a timestamp, an epoch time, milliseconds. Here's the job type, the job ID, and the job or the event type. And then you start seeing all these things, and it's kind of hard to tell what's the difference between that number, that number, that number, that number, and that number. And the reason is because they're space delimited, and where it appears in the event in the line, that's the column it's in, and that tells you what it means. So not very human readable. And to make matters worse, some events have different orders of things. So the documentation does explain the format, so it is possible to decode this, but with a wikified event here, it's much more human readable. At least I think so. And it's much easier, at least for me, to write a Perl or Python script to decompose this into a dictionary. So it starts out the same. Then we start to see, instead of just numbers and spaces, we actually say, oh, requested node count equals 1. Requested task count equals 1. These numbers mean submit time, dispatch time, start time, and so forth. Much nicer. And it's going to tell you the user and information with the host list, the task map, and so forth. Okay, so we know how to find out what happened in the past, but how can we maybe get a glimpse into the future about what will happen if I turn on this configuration setting? What happens when I enable this policy? And you have to be careful because a lot of you guys are using production systems here. You just can't turn on features willy-nilly. Those of you who are lucky, you have a tests cluster, but maybe it's not very big, and maybe a policy will work well at small, but at scale it's not going to work out. So is there a way that we can do this? There is. We can use a native RM simulation, of course, but what is a native RM? So let's talk about it real quick. A native resource manager is a special kind of resource manager that Moab uses to read from a script or file to find out about resources or workloads. Now, Lawrence Berkeley actually had a demo or a presentation yesterday that showed them using a native resource manager to inject into Moab information about werewolf preferences. I may be getting the reference a little bit wrong, but I just glanced in briefly and saw that. So they were using a native resource manager, and maybe many of you are as well. But why call it native RM? It uses the Moab RM language, formerly called Wiki, that we talked about, to describe information about the resources or workload in the system. So you could actually control jobs with this. And it's called native because we're taking foreign data from outside of Moab and we're adapting it, making it native to Moab. So that's where we kind of get the native RM thing. And two more important things about this. The native RM, like other resource managers, is going to be pulled every scheduling iteration. And some of you may have learned through experience, the order that the resource managers are in the Moab configuration file matters. They really do. So you want to be careful. Your native RMs, when you're setting this up, we'll talk about this a little bit later, needs to be at the very bottom so that nothing else is overriding it. Because if you have two RMs and they're reporting the same resource, and one says he has this much memory and this one says that he has this much memory, the last one wins. Okay, so native RM makes sense. So let's talk about simulation. So we're going to talk about in the next couple slides. Here's a little quick overview. We're going to talk about how you can simulate your own live system to a large degree using a resource trace that looks just like your system. And then you'll be able to actually test policies and configuration and restart Moab and do all kinds of things with it because it's not your actual live system. So you can make mistakes and not pay the consequences. And you also can use slightly modified versions of your own workload to get them to run in the simulation and see how they might perform or interact. Now, this is a little bit different than the simulation that may be in the documentation. There's kind of two types. This is the native RM one. I keep saying that, native RM. It's different than the simulation that you may find in the documentation. And that is one that's you can take historical records of workload and play them through Moab very quickly. That's also very useful. But this here is more of an interactive, kind of a slower thing. But you can also, through scripts and so forth, replay workload. But you can't speed up time yet. I kind of do that yet with the Wink because that is something that we're working on, but it's not official yet. So, a little teaser, I guess. So, to get a little bit more detailed about the process, we'll go on. We're going to copy the Moab home directory, add the RM CFGs in there to actually configure the new native resource managers. We're going to get a resource trace and hook that up to our new native resource manager. And then we're going to run our tests on our head node. Now, it's important it's the head node because you all have a license file for Moab. And as you know, that's tied to your head node. So you have to, in most cases, unless you have a license that allows other things to occur, run these tests on your head node. And you just copy the direct, you're going to make a second copy of Moab. Let's go into that right now. So you need to copy your Moab home directory. You want to ensure that the new home directory is on the same head node, like I just said. And make sure it's in an area or location that's very different from the production one so you don't make any mistakes. First thing you need to do is edit that Moab config file to change the port, because if you try to launch two Moabs on the same port, obviously it's not going to work. And then you want to comment all of the resource manager configs in that file, unless you have some in there that you want to leave up for the simulation and you know what you're doing. If you don't comment them all out, you may launch this Moab, and it may try to communicate with your resource manager, Torque, for example, and may try to take action on your production system. So you've got to comment them all out. Do a search and make sure they're all commented out. Okay, I just can't stress that enough, because I don't want you guys to make mistakes. And then you want to create your new RMCFG lines for the native resource manager at the very bottom of the file we talked about earlier. All right, and then once we've done that, we're going to run a command, and I'm going to show you all these commands in the slides too. We're going to run the following command, you see there on the screen, and type it to a file, or redirect it to a file. And that's going to tell Moab in your production system, you do this against your production system, say, get me the resources in wiki format, put in this file, so I can use it for my simulator. Then you're going to start up Moab. This is actually out of order. It says check the new RM, it actually goes after starting up Moab. So you're going to start up the new simulation Moab, and then you're going to use that command to make sure that the new RM you defined is looking okay and it's reporting what you expect. Then you can use Moab as usual and submit jobs with this particular flag here. This is your modified workload submission I talked about with the -O flags equals no RM start. If you add this flag to your jobs, they don't actually ever start in a resource manager. Moab just pretends they do, and they will run to their wall time and then complete successfully. And then you can, of course, configure to your heart's content. So here's an example Moab config file. Here's where you change the port. Here you see I've commented out or removed all RMCFGs previously there. And then I've added type native cluster query URL, which is saying this is the file you're going to pull in, or the script you're going to pull in information from to define resources for the system. And it's this nodes.txt file. And then what we've done here is then we put our resource trace into that nodes.txt file. Here's an example of what it looks like. We're going to make sure our Moab home directory is set to the new home directory and start up Moab. And then we're going to run this command to look at the resource manager we just configured and make sure it looks good. What you want to see is this, state equals active. And you want to see that it does have some nodes reported. And hopefully it's the same amount of nodes you would expect. And then you can run all the other Moab commands and it will look like you're on your system. This is the same slide. All right, and this is an example of how you might submit a job using this command. So you may have noticed I'm using msub. Unfortunately, this simulation does not work using torque. What I mean by that is you can't use qsub to submit the jobs. However, you can symlink, make a symlink to msub that's called qsub and put it in this new location, and it will act like qsub. A pretty good approximation, at least, maybe for your simulation and your testing. So that's one way to get around this limitation. All right, to learn more, you can go to these resources, 13.5, to learn about the native interface, and Appendix W for the Wiki interface specification. So you know you could add stuff to the file after the resource trace and play around with things. Okay, so I want to talk to you a little bit about what's coming down the road. Let's make sure I get the time check here. I've got about, well, I'll try to hurry so that if there's any questions afterwards. Okay, coming in the next release of Moab, which is codenamed Evans, we have some things that we're excited about. We have a new task-based policy management in the GUI. It's not going to be all of our policies, not all of our high-level policies, I should say, but it's going to be the beginning of a new world in the sense that you will have the ability to configure some of these in a much easier way from the GUI, and we'll be adding more and more with subsequent releases. You're going to always be able to edit them from the configuration file, or from the command line, or from the web services. So we're also going to have improved audit and event logging. Since it's so important to tracking down problems in Moab or understanding how the system is going, we want to make it even better. We want to make it so that they're even more, they have more information in them. We don't have too much information in them, and we want them to be traceable. What I mean by that is that if you have a job or event, all the way from the GUI down to gold, from Moab to the RM, I want you to be able to go to one single source and say, show me everything about that job. And it will show you every event that happened from the viewpoint, if you're using it, Moab, the torque, gold, or other resource manager level. And the nice thing is that you can actually, with your stuff that you've built around Moab, write events to this as well. So it's kind of like a syslog for the Moab ecosystem. So it's cross-suite. It's web service enabled, meaning that you're going to be able to query the web service API to get these events out of Moab, and they're going to be stored in the database and be indexed. They're also going to be in flat files, so that tools like Splunk and other log aggregation tools can consume them, and you can aggregate them yourself, and use grep and other tools as you may see fit. So here's some screenshots. Now notice there's a preview only thing there. Maybe you can't see it up there, but these are high-res mockups. What you actually get may be a little bit different, but they look pretty close to this. Here you're going to have a list of policies, and you're going to be able to click on these high-level policies here and drill into some more configuration. Here you can see these ones are on, these ones are off, and these ones are in conflict, because as you may know, not all policies in Moab are compatible. Here's a drill down into one of them, node allocation policy. I'm going to go kind of quickly so I have enough time here. Some of these are cloud-centric. I just threw them in from another slide deck. Virtual machine migration. Here's a policy setting for overcommit of your servers, and so forth. Okay, now let's talk about the events. The events I want to get just a little bit, help you understand a little bit more what's coming and why I'm personally so excited about them. We actually have this is a UML-ish. I'm not very good at UML. So it looks like it, but it's not exactly it. So don't be too harsh on me. Of what the data model might look like. This is again a preview for the event files. It's going to look very close to this though. Every event, they're going to have things in common. It's kind of these green things, these green colors. And then there's different subtypes of events here that of course have specific information about them. You're also going to get a serialized copy of the objects in Moab in the event files for key events, so that you could reconstruct those events if you needed to for simulation or something maybe in the future. So Moab Man is not a marketer, he's a hacker, so he wants to see an actual example of the event file format, and here it is. It looks similar to the Wikified events, but it's a little bit different. You'll notice that we have a few more information, a few more bits of information here, a few more data that you can search for or trace through. And there's also going to, it shows you here your primary object. It's also going to have relates to predicates that you can search against as well. So So hopefully this presentation has been valuable to you and you've been able to get a taste of some of the secrets, tips and tricks, whatever you want to call it, of Moab policy. We've only scratched the surface really though, but these tools will hopefully help you be able to experiment yourself and get help from our support and consulting services to make sure you're going to be able to find out how to use Moab to its greatest ability. And once you've done that, you will have the power of the three-wolf moon. And you too can become like Moab Man and protect the user.